First of all, let me start by thanking Gary. Thank you very much for those kind words. And for your next night out in town, be sure to check out our lift truck. I think they're wonderful. Well, good afternoon. I know it's kind of late, so I'll try to go as quickly as possible. My biggest job right now is to keep you awake. But I trust you have all enjoyed a very productive conference. Well, at least up to this point. I think the conference planners in the Industry Week did a terrific job this time organizing the event, don't you? Now, yesterday and earlier today, you heard presentations on quality improvements, lean business strategy, Six Sigma, Hoshin planning, Kanban, and many other related subjects. It's now quite difficult for me, it's a real difficult task for me to come and close this meeting, and especially because of your very diverse knowledge base. At first, I wrote this presentation as an in-depth technical treatment of TPS as we know it, and I rewrote it. I rewrote it from a CEO's total organizational viewpoint, which is quite different. So what I'll end up sharing with you today is kind of a hybrid. My hope is that all of you will take home something, some new ideas and concepts from what I'm telling you and what we are doing to further improve your own business performance. First, I would like to tell you a little bit more about ourselves. Most of you are very familiar with Toyota Motor Corporation, or TMC, which is today a $170 billion company. TMC was actually started as a division of our parent company, Toyota Automatic Loom Works, now known as Toyota Industries Corporation, or TICO. Today, TICO is nearly a $15 billion company. It earned the 28th position in Fortune magazine's list of world's 50 most admired companies. TICO encompasses several diverse business segments. It includes textile machinery and logistics, as well as our two core business areas. And these core business areas are automobile and material handling. Within the automobile segment, which accounts for nearly half of TICO's consolidated net sales, we manufacture the Yaris and the RAV4, diesel and gasoline engines, compressors and power electronic devices. And in the material handling, we manufacture lift trucks, of course, automatic guided vehicle systems, and other material handling and logistics products. Now, here's a real quick review of our sales and manufacturing of lift trucks in the United States. With a focus on customers and Toyota Production System, Toyota has grown steadily in the United States material handling market. Toyota entered the market in 1967. Clark, Hyster, Yale, and Caterpillar were among the top full-line lift truck suppliers in North America. In 1990, along with increasing our market share to 6%, we started production in North America at Toyota Industrial Equipment Manufacturing, or TEAM, which some of you visited yesterday in Columbus, and we really want to thank you for doing that. By 2002, we were #1 in the United States. Today, Toyota is the leading North American lift truck supplier for 5 years running with nearly 19% market share. Toyota is also the #1 lift truck manufacturer worldwide with 24% global market share. Toyota entered the United States, as I said, in 1967 by exporting from Japan. On the screen, what you see is our very, very first truck that we ever sold in the United States. As demand increased, it made sense to build a plant here in Columbus, Indiana. The first US-built truck rolled off team production line in 1990. We started with about 280,000 square feet. Over the years, we have added a distribution center, a service parts center, our national training and customer centers. It brought Team's total footprint nearly to 900,000 square feet, more than triple its original size. But what's much more interesting is how our production capacity has grown. In 1990, Team produced 1,835 trucks. That's their first year. Today, we produce nearly 33,000 trucks 18 times more than what we produced in that first year. I'm a Peter Drucker disciple. Peter Drucker perhaps is the best management guru of our times. He says, a product is not quality because it is hard to make and costs a lot of money. Customers pay only for what is of use to them and gives them value. Nothing else constitutes quality. According to a Reed Research study, and we don't have J.D. Power study, customers rank Toyota lift trucks as #1 in quality and #1 in value in the last 3 years and as long as the study has been conducted. And we have Toyota Production System to help us for achieving that honor. My point is this team is clearly a very productive Toyota plant, much like the majority of the manufacturing plants that are represented by you here today. Well, as many of you know, U.S. manufacturers have made enormous gains in productivity over the past 2 decades and are continuing to do so. I recall those days back in the 80s when U.S. productivity in various industries started falling behind the Asian countries. Many of the so-called experts were predicting its slow demise. Most of the manufacturing jobs would eventually go offshore where labor, raw material costs were lower, was the claim. What's interesting is that today you hear the same claims about service sector jobs. Well, these claims are well known and well publicized. What is much less publicized, however, is the fact that U.S. manufacturing productivity doubled in the last 20 years, from $89 per hour to $178 per hour per person, indexed to productivity of 1992. In many industry segments, U.S. companies are now world-class and setting the pace. Through cost-cutting, downsizing, re-engineering, lean manufacturing, America now boasts some of the most productive manufacturing plants in the world. A great number of these plants are represented here today, and most of you have been in the manufacturing industry for quite a while. In other words, you are all have had a hand in helping achieve these very impressive productivity gains in the U.S. You've helped America be what it is today, a leading nation of the manufacturing productivity. So, does this mean that we can now rest on our laurels? Hell no is my very, very clear answer to you. We must continue to improve, especially in light of the continued threats to U.S. manufacturing. If we even slow down our pace, we can get passed by the EU and Asian countries, especially industrial giants like China of today and India of a few years from now. Our challenge is to take our already highly productive plants in the U.S. to new heights. Last year, in a joint Industry Week and Bearing Point survey, senior manufacturing executives, and maybe perhaps some of you here, rated productivity as more important than cutting costs. A proven way to attain continuous productivity improvement while lowering costs simultaneously is by using something that's a very big part of all of our daily lives. Obviously, that's the Toyota Production System, or TPS. And up till now, I haven't said anything about TPS. Are you still with me now? All right. Today, I will review TPS as we know it and share with you some of the history behind its basic principle. It's really interesting history. I'll give you examples of how TPS has grown beyond manufacturing to incorporate lean thinking into businesses both inside and outside of manufacturing here in North America and elsewhere. Here's a little bit of history. In March of 1937, Toyota Motor Company was formed, and the construction of the Koromo plant was decided upon at Toyota Automatic Loom Works board meeting. That was the parent company. But before construction began, Kiichiro Toyoda had formulated a flow production system instead of a lot production system for Koromo's production line. Kiichiro's manual is a really impressive one. It was a full 4-inch thick manual. What Kiichiro had in mind was to produce needed quantities of required parts each day. Now, to make this a reality, every single operation had to be converted into a flow production system. Kiichiro referred to this as the just-in-time concept. According to Eiji Toyoda, our ex-chairman of Toyota Motor Corporation, the system and the concepts that Kiichiro had taken such pains to teach and instill in Toyota associates was totally dismantled soon after the start of the World War II. Following the war, Taiichi Ono, former executive vice president of Toyota, revived and further refined the system using the now legendary Kanban cards. By 1975, the production method that has been conceived 4 decades prior was fleshed out. When people at Toyota, this is really interesting, when people at Toyota wanted to refer to it at that time in the 70s, they called it the mustaches method. They didn't have a name, in deference to Ono's nickname. Since the mid-70s, TPS has gone through several upgrades within Toyota and continues to do so. In fact, this production system didn't even have its name until others who tried to understand why Toyota is making so much money or being so profitable started calling it the Toyota production system. The basic purpose of our company, I want to start there as the foundation of TPS. The basic purpose of our company, or the reason for existence, is as follows. Please follow the slides if you would with me. First of all, we will see at the bottom that our company must make profit to continue to exist or survive. Survival, of course, is number one. Once these needs are met, then in ascending orders, we take care of the employees, the society, then the customers. The basic philosophy of TPS is that no cost reduction, with no cost reduction, there is no profit increase. On the slide, you will see that profit equals sales price minus cost. Profit can be increased by either raising sales price or by reducing cost. If one believes that sales price is determined by the customer based on the product's perceived value, then cost reduction is the way to improve profits. This is one of the fundamental precepts of TPS. The components of cost are very common among the competing companies. All of them have the same raw material cost, parts cost, labor cost, energy cost, and so on. But extra cost is introduced by differences in the production method. Therefore, cost depends on the production method. Traditional lot size production creates waste. Continuous flow production reduces many different kinds of waste. From this point on, I'll call it muda. Therefore, continuous production generates lower production cost. Another additional philosophy is that muda exists everywhere. For example, if you break down an operator's motion, what he does, at the first level, we find that there's work and then there's unnecessary motion, or A in the slide. Then when we break down the operator's work now, we find B, which is incidental work, which is non-value-added work, but needed under the present work conditions. In this particular slide, operator's total work motion, off that total work motion, net work achieved is only C. I give you just some of the fundamental philosophies. So based on these fundamental philosophies, JIT was developed. Again, going back in history, in 1937, Ford and GM were selling trucks in Japan to their dealers for around, astounding number, 2,400 yen. Anybody wants to guess what that in dollars today is? Will be around $20. This is 1937. Kiichiro argued that by using continuous flow production and reducing the muda of unnecessary motion and incidental work, as we just described, Toyota could produce trucks for 1,850 yen. By supplying the dealers at 2,400 yen, they would make a handsome profit. And this is the start of the Toyota Motor Corporation. Taiichi Ono described the environment at that time as such. Above all, one of our most important purposes was increase productivity and reduce cost, again at the starting point in early 40s. Now, let's travel travel to today, and we today at Toyota define TPS as such. TPS is a system of manufacturing that results in the elimination of waste and full utilization of human resources, equipment, and material. On the screen, you will see a visual representation of the framework of TPS. At the top, you will see the highest primary goals of highest quality, lowest cost, and shortest lead time. They're all simultaneous. Just-in-time and Jidoka are the two pillars that support these goals, that on the foundation is represented by Haijunka, standardized work, and Kaizen. Most of you know these terms. Highest quality and the lowest cost, all those somewhat self-explanatory, needs to be technically defined. But here, one can benchmark competition to determine the lowest cost and the highest quality in its own class or category. But what do we mean by the shortest lead time? We define lead time as the time between production plan, production, distribution, and sales, the total time. Another way of looking at this is the time to collect money between sales and production plan. Production lead time, I should say, equals the processing time or the assembly time plus stagnation time. Now it's here very important to elaborate on this concept of stagnation time. Here is an example of a stamping process. From the coil through blanking and stamping, a part is produced for assembly. The total production lead time is 600 minutes and 2 seconds, where the processing time is only 2 seconds and stagnation time is 600 minutes. Reducing stagnation time is then key to shorter production lead times. The root causes of stagnation in the production process are 4. Large lot size, complicated production flow, a very weak belief in the parts of production people that production pace must keep equal to sales pace, and I'll elaborate on that. And finally, poor methods of conveyance, what we call logistics today. Thus, to obtain the shortest production lead time, we must address all of these 4 areas. Let's take a look at how this large lot size prolongs lead times. In this example, production lead time is 10 days, even though processing time is 1 hour. Here, the last piece will be used 10 days and 1 hour later, and the sales pace of the following process becomes apparent only after 10 days. So you have to kind of stay with me on the slides, so please follow the slides. I try to shorten it as much as you can. A better process for this case would be to have a 1 hour lot size. This leads to a shorter lead times, less inventory, and less risk of market change. Here, the last piece would be used only 2 hours later, which means the sales pace becomes apparent only after 2 hours. Now let's take a look at how complicated flow prolongs lead times. First, on a macroscopic flow or relying on outside vendors. In this example, relying on outside vendors more often than necessary is wasteful and prolongs lead time. By producing it in-house with inexpensive machinery, this company can theoretically decrease its lead time by 5 days. In the microscopic flow, even when production is completely internal, an overly complicated flow leads to stagnation. The flow of parts is inconsistent, and it becomes difficult to tell when finished goods will come out of the line after the first production instructions are given. Furthermore, with so many elements on this slide, it's very hard to find where the real muda is. So by straightening out the process flow and producing parts one at a time rather than a batch, this company will decrease the lot size, eliminate inventory stock, and control costs. Now we turn to the problem of weak belief of producing parts at the same rate as sales. In other words, let me clarify by saying production management must be convinced that production should be at the sales pace. By doing so, we produce exactly what is demanded by the customer. Takt time, as you know, tells you how much time should be spent producing a single finished product. Never produce parts by operator or machine capacity is our motto. Finally, let's turn to the stagnation as a result of poor methods of conveyance or logistics. Conveyance or logistics is the most common form of muda or non-value added operation. Eliminating conveyance muda through just-in-time production is one of the best ways to reduce cost and therefore increase profitability. Here's an example. If a truck is filled 100% with a large lot, it's logical to think that cost is reduced. However, this is true only for the truck process. Remember, total productivity against sales is more important than individual productivity. This first diagram shows the traditional process of conveyance. Here, each supplier ships 10 tons of parts per day, whether they are needed or not. In the next scenario, one truck is needed to make a milk run from all 3 suppliers. This ensures that all parts are available when needed and reduces the cost of conveyance. This process also helps reduce the buildup of inventory. Let me elaborate further. On the top portion of the slide, you will see 4 cycles. 2 trucks and 2 drivers are required to make a delivery of 40 tons of parts. Now we change the system and use Kaizen. With the truck transfer system, which is bottom of the slide, 3 trucks rotate in and out like cookie sheet, 1 in and 1 out. To achieve the same 40-ton capacity per shift, it now requires 3 trucks, but only 1 driver. This results in 1 hour of conveyance rather than 3. Therefore, by using smaller lot size, streamlining production flow, matching production to sales, and good logistics, one can obtain the shortest lead times. And hang on, I will give you examples how team does it in a few minutes. As I said earlier, just-in-time was developed by Keiichiro Toyoda, the founder of Toyota Motor Corporation. As many of you know, just-in-time, or JIT, is producing only what is needed, when it is needed, and in the amount that is needed. Each company has its own level of just-in-time, and it changes with time. It can be monthly, it can be daily, it can be hourly, and it's really based on the company's lead time from production plan to sales. The biggest difference between traditional and just-in-time manufacturing is that traditional manufacturing production lines use, as you all know, the push system, in which parts are moved down the line as quickly as possible with the goal of completion. This really can affect your quality and can result in overproduction. Just-in-time creates the pull system, in which each process takes part from the preceding process only when that process is ready for the parts and parts have been quality inspected. There are really 2 components to it. In the pull system, you make only what is withdrawn in the sequence it is withdrawn 1 piece at a time. At the end of the continuous production cycle, the completed part is placed in the end of the process where it's pulled for the next process. In this way, quality is built in with the reduction of inventory. Well, Kanban is a word simply means signboards, cards, and chits. The Kanban system is an essential element in maintaining just-in-time production. Kanban cards are used to track parts usage that enables the pull system in a continuous flow production line. Through continuous improvement, Kanban has evolved today into e-Kanban, which is managed through IT and increases productivity even further. Now, I sat through some of your earlier sessions, and I saw the use of IT here. It was very, very encouraging. Today, very similarly, at Team, e-Kanban is connected to all its major suppliers, where they manufacture components for the next day's production of Team. The majority of our parts come from suppliers that are they are in very fair proximity to us. Rather than waiting for each supplier to have a full load of parts delivered, we send the truck on a milk run. Suppliers are an integral part and partner in the TPS system. Team has about 65 core suppliers that account for nearly 75% of its domestic components. We have constant meetings with them, and seldom do we change suppliers. Nowadays, we are making 13 milk runs per day. 13 milk runs per day to collect parts. It goes as far north as Michigan, as far east as West Virginia, Atlanta in the south, and Missouri in the west. Other suppliers deliver to us sometimes several times per day, as in the case of steel. Now let's take a look at the other pillar of TPS, what we call Jidoka. The concept of Jidoka was developed by Kiichiro's father, Sakichi Toyoda, the founder of the company. Sakichi developed and produced the initial main product of the Toyota company, and that's the weaving loom. It was Sakichi who invented a loom that would automatically stop when a thread broke. Jidoka is the process of stopping and notifying supervisors under two conditions: when the process is finished, and in the case of any abnormalities in the line. The end result is a better, defect-free product at a reasonable price. Jidoka is meant to prevent defective components and parts from being passed down the production line from one process to the next. This allows us to produce quality goods the first time, meaning better products at lower cost. Today, we have machines that sense abnormalities and either self-stop or alert workers. What this means is that workers do not have to watch over the machine. This separates human and machine work and allows the plant to operate with less labor. An important point to note is the associates themselves have the power and the obligation. People miss that. They have the obligation to stop the production line when a problem is identified or even suspected. This ensures that problems are fixed at the source and are not embedded in the final product. Rather than viewing this as a negative, we see this as a sign that we are ensuring a defect-free product. Visual control is an essential element of Jidoka. This slide shows the and-on board at Team's assembly plant. It allows everyone in the plant to have the same information at the same time. The numbers at the top show the daily production target and the number produced at any given time. Below, there are 2 rows of numbers representing 22 processing areas for this main assembly line. When a number lights up in the yellow row, that means assistance is needed in that area to avoid production delays. The assistant team leader would come out there. When a number is lit up in the red row, that line has been stopped due to a problem in that area and needs fixing. By stopping the line, we avoid passing bad work to the next process. On the bottom, overtime is automatically calculated throughout the day based on production delays or stoppage. Problem identification and problem solving, mostly called taking countermeasures in our culture, is itself a large part of Jidoka. This practice makes Toyota truly a learning organization, continuously improving production process. At CVI, or Complete Vehicle Inspection Quality Assurance, inspects the finished product. Any defect is posted. Team leaders have to check the CVI report multiple times a day for defects. The cause of the problem is determined, a countermeasure is written, and an assistant team leader, and has to be approved by management and then discussed with the associate prior to the start of the next production day at 6:30 in the morning. Let me move on to the foundation of TPS, Haijunka, standardized work, and Kaizen. As you see in this visual, traditional production systems tend to produce products or components in batches. Haijunka, on the other hand, is producing a mixture of parts and components and products. As in the bottom example, to ensure that each product is available in the shortest production cycle possible. The amount of time required to produce each product is the same in both examples, but by leveling out production of different parts and products, we can better meet customer needs. Perhaps an example will clarify. This oil heater manufacturing company produces 12 types of oil heaters. Call them type A through type L. Before Kaizen, they were producing each type of oil heater in a batch process once a year. This meant that each product had a 1-year lead time. After Kaizen, the company produced every type of oil heater every month. This reduces both lead times and inventory buildup of oil heaters to the customer. And the customer can be very well the next process. Standardized work means processes are completed in a consistent, timely, and repeatable manner. Takt Time is a key component of this. As you all know, Takt Time tells you how much time should be spent producing the finished product. It's calculated as a number of regular working hours divided by the total daily production requirement, which is driven by, for us, definitely by the customer demands and sales. Again, for taking the example of team, 8 hours a shift equates to 480 minutes. After subtracting the 24 minutes for break time, which is the case for team, the total available production time equals 556 minutes. At team, today's production requirement is 96 trucks on our main assembly line. Therefore, the takt time is 4.7 minutes per truck to meet the sales requirement. Here's the trick, of course. All the 22 processes of the continuous flow production line now must have their own process times to meet the takt time of 4.7 minutes. Obviously, some of our lift trucks have options that are more complicated and complex to build. In this case, we add a relief person to help balance the process time so that we can continue to build and keep the takt time at 4.7 minutes among the 22 processes. As sales fluctuate, we do adjust the takt time. Just for clarification purposes, based on what we have heard yesterday as far as questions, our lead time is 60 to 65 days. You place an order today, you probably get it 60 to 65 days for a standard truck. Processing time for assembly is 2 days. That means when we start the process of manufacturing with the frame assembly to the final CVI, that's 2 days. Our takt time runs between 4.7 to 5 minutes per day. Now let's turn to Kaizen. Kaizen, of course, refers to continuous improvement, as you have heard over and over again, especially in the elimination of waste and muda. So I'll spend a little bit of time on this muda. Muda refers to any unnecessary activity in the production operation. There are several types of muda, including waiting, where a team member or part cannot proceed to the next process; motion, which refers to any human movement that adds no value; conveyance, or the wasteful activity of moving things from one place to another; correction and recertification of a product that did not initially meet quality standards; and the number one reason for muda is overproduction or building ahead. When production requirements are based on the pace of sales, you produce exactly what is demanded by the customer. This is ideal. Let me describe our process, how we do it. 3 times a month, we hold joint sales and production meetings. We call it the JSP meetings. From this, we forecast parts for production and provide suppliers 30-day, 60-day forecasts. Then we lock in production in 10-day buckets. An electronic mailbox, which is now our Kanban system, orders daily parts for milk runs. Production at team, therefore, is clearly sales-driven. We actually build only to order, results in less time and this results in less time to market than most of the other material handling manufacturers. Many manufacturers are tempted to overproduce when they have excess manpower and machinery and feel the need to keep them busy. Plants also overproduce as a safeguard to have emergency stock available for downtime or to replace defects. We call this wasteful process just-in-case production. It is the nemesis of just-in-time production. Unfortunately, overproduction increases other areas of muda, such as muda of conveyance. With excess inventory, there is increased waiting for parts and people, increased need for pallets and boxes, increased needs for warehousing space, increased need for material handling equipment. Well, certainly I'm all for you needing more material handling equipment. I can use the business. However, my mission today is to keep your muda the lowest level possible. It's human nature to want to be productive and even to overachieve. I'll give you some examples because I feel this is a pretty important point. Imagine as a foreman, I normally produce 100 units by 10 operators. Now, if I produce 120 units with 10 operators, my apparent productivity is 120 units per day. That's a 20% increase. Somebody ought to give me a bonus that day. But what if I only need 100 per day to meet sales need? That's all my sales demand is. In that case, I just overproduce 20 units. Now, if I produce same 100 units with only 9 operators, I can meet demand with less labor resources and therefore less cost. Conceptually, it's easy. I know transactionally it may be difficult. But this is productivity against sales or demand. The key point is that total productivity must be measured against sales. This is more important than individual productivity. And let me give you a very simple example. Imagine a boat race, rowing boat race. If each person is rowing at the same pace, the boat will stay on course and get to the finish line fast. If one person, on the other hand, is rowing faster, the boat will definitely go off course and take longer to reach the finish line. Therefore, I suggest design and measure team productivity against sales as opposed to individual productivity or apparent productivity. Now let's look at this from a manufacturing standpoint. This bearing plant needs to machine both inner and outer components of an extra large bearing. If one line is moving faster than the other line, inventory will build up. Again, unnecessary inventory buildup will create non-value added work or muda. All this non-value adding work is muda, muda of motion, muda of conveyance. In this example, machining line of the outer race should determine the takt time to avoid muda. As I said, Kaizen activities are meant to eliminate all that wasted activity, lower our cost, and increase our overall productivity. Kaizen happens when every manager and every associate questions every motion, every item of in-process stock, and every second that associates, material, and machine spend idle and ask themselves these questions. Is there another way to do this job that takes less time? Is there another way to do this job that improves quality? Where is the waste in the process? At Team, we encourage all associates to submit Kaizen ideas on a regular basis. It's very interesting to hear the discussion right before this presentation, and we'll give what we do at Team. Our target is 3 ideas per month per associate. 3 per month per associate. Team leaders review the ideas, and if there are no adverse effects on the quality of the product, we implement those ideas almost immediately. In a typical month, we will receive 1,200 to 1,500 Kaizen suggestions from our associates, sometimes as many as 2,500. Our goal to implement these ideas is within 20 days, and we are running now 26 days. This is idea submission to implementation. If we require something special engineering, it may take a bit longer, but usually we can implement about 90% of those ideas within the 20 to 26 days. Awards are given on a monthly basis by departments, but as you heard, recognition in that culture is much more important. One idea is selected on a quarterly basis for a price, and it's a very humble price, such as a DVD player. Here, the key to participation is to have no fear of job loss. And I cannot emphasize that enough. Only improvement in the job or process is what we're driving at, and the employee needs to understand and believe in it. Implementing Kaizen ideas quickly leads to positive reinforcement of the importance of this philosophy and generates really good excitement and more ideas from our associates. And I'll give you some examples. Here's one that addressed the muda of motion. Gary Boswell, in our painting area, had to mask off and paint around a tank outlet several times a day, as you see it in the picture. One day he found like a little paper cup, and that exactly fit the size of that outlet, and he covered that outlet and he started painting with that. That was his Kaizen idea number one. Later on, that cup was replaced by this plug, his second Kaizen idea. Today, he gets the same job done in the fraction of a time and cost. These ideas may be very small, and even the smallest ideas can have significant financial and process time impact on your business. You can hardly see this one, so I may have to kind of say this. The form that you see on the screen represents a safety-related submission by a team associate. As you can see, you can submit by just by handwritten drawing, and artistic ability is really not a requirement. On that side, on the far side, on your left side, you will see that the associate had to manually extend the lift cylinders, which put undue strain on the arms and back. The suggested Kaizen was to build a tool using a piece of rubber tubing and a standard blowgun. The tool blows compressed air into the cylinder to extend it. This Kaizen idea resulted in reduced risk of injury. Here's another example. Our production engineering group reduced the cost of a key component, a hydraulic lift cylinder, by bringing it in-house. This resulted in the cost savings of $2.5 million per year. Yesterday, a number of you asked about team's organizational structure. So here it is. Today, we have about 840 full-time and 120 temporary associates. About 550 of them are hourly production line associates considered to be direct labor. 17 production engineers, very, very thin. 18 maintenance personnel, that's it. And 6 people in the Kaizen team. The organizational structure is as follows. The line associates report to an assistant team leader who reports to a team leader. All these are about 5 to 6 span of control. Then they report to supervisors who reports to assistant managers. They report to managers, to senior managers, to VP. By this time, you may be wondering, how do we find people like this to work at team? People who look for ideas in everything they do. Culture, culture, culture. How do you do it? As you can guess by now, new team associates do not necessarily embrace TPS ideals the first day at work. However, we do our best to stack the odds in our favor by carefully screening the people we think will work well in a team environment. In fact, we conduct at least 2 group interviews with each candidate to give us an idea of whether or not they are a good fit. An associate's first 2 weeks on the job are spent in training and training alone, both in the classroom and at the actual work site, a process that we call assimilation. This is how we introduce them to our TPS culture. The training starts with safety, which is the #1 concern, then moves on to achieving quality through Toyota Production System. We also conduct ongoing training for associates at all levels of the organization, either internally or at a nearby educational institution. I do get asked, so I give you my rough estimate. I think it takes about 3 to 5 years for an associate to truly adopt TPS and internalize it. Well, that's why we invest so much time and resources in recruiting and training. As a result, we have seen a 70% reduction in staff turnover since 1990, from 30% now to close to about 9%. The results of TPS have been spectacular for Toyota. Labor productivity is the highest among the automotive industries of major countries. The return on asset is extremely high. In fact, it is the highest of all automotive companies. Third one is an important one. Suggestions to improve and their acceptance show workers positively participate in improvement. As Gary introduced me today, you heard my presentation topic is titled Leadership in Manufacturing. According to General Colin Powell, leadership is the art of accomplishing more than the science of management says it is possible. And the effectiveness of leadership is measured by its organizational results. Toyota is now ranked second after GE in Fortune's most admired global companies. And in today's paper, as Gary already said, you see that the first time since 1920, Toyota has surpassed GM's global auto sales for the first quarter of 2007. TPS has now evolved into a world-class production system. In their landmark book, The Machine That Changed the World, Womack, Jones, and Ross popularized TPS and called it the lean production. In their next book, Lean Thinking, they argue that managers have lost sight of creating value for customers. Now we're gravitating from manufacturing to something else. TPS, lean manufacturing, lean thinking, TQM, Hoshin Kanri, the Toyota way. All this gets to be rather confusing for most outside the Toyota family and for many within the Toyota family. So let me see if I can clear up some of this by explaining the diagram on the screen. And some of this will fit very nicely what you have heard over the last 2 days. From an organizational standpoint within Toyota, TQM is the total quality management. That's the triangle or pyramid, whatever you want to call it. It encompasses all the functions and activities within the pyramid. At the top is the management activities of Hoshin Kanri. Plant activities of TQM are quality control circles, Toyota production system, and Toyota productive maintenance. On the office side of the activities are design review or DR, statistical quality control, SQC, cost management, and accounting. All of this is founded in the Toyota perspectives and viewpoint of QC, making this entire triangle what we call the Toyota way. Hoshin Kanri is defined, as some of you have heard in one session, the organizational system designed to improve the performance of total organization and produce good results. Hoshin means setting direction, policy, strategy, and plan. It involves setting and prioritizing. The important part is prioritizing targets and engaging all levels of organization to clarify their own targets and strategies. Kanri relates to management, control, and administrative activities. Here, the activities are the so-called PDCA, or plan, do, check, action of the Hoshin. Based on the strategies, action plans are created, then they are constantly implemented, results are evaluated, and appropriate steps are taken. The last part, as the panel said, is very, very important. It's the most important part. After plan, do, the check and action, and start it all over again. Put together, Hoshin Kanri allows the organization to unify its efforts and move together in the same direction. Thus, each functional leader at Toyota, like myself, has a midterm as well as an annual Hoshin Kanri for the entire company and their own areas. I thought you might like how all these things fit together. In 2004, Jeffrey Liker published The Toyota Way, 14 management principles from the world's greatest manufacturer. In it, he outlined the 14 management principles behind our world-famous system of lean production. Well, I'm going to deviate and say something a little different here. In the late 90s, we at Toyota worked very hard to formulate and put down on paper exactly what is it that we do, what drives us, and what is our fundamental culture and philosophy on a global basis. In short, what we said, we're going to set out and define our own DNA. As a result, Toyota Way 2001 was born. This is Toyota's Toyota Way 2001, a little different. Actually, it's entirely different from Liker's perspective. The Toyota Way 2001 is an ideal, a standard, and a guiding beacon for the people, for the global Toyota organization. It expresses the beliefs and values shared by all of us. The Toyota Way 2001 is supported by two pillars. It's called the continuous improvement and respect for people. Under continuous improvement, there are three commitments. Challenge. Form a long-term vision, make challenges with courage and creativity to realize our dreams. Kaizen. Improve our business operations continuously, always striving for innovations and evolution. This one, some of you may know or may not. Third one is Genji Genbutsu. Genji Genbutsu is a practice of going and seeing. Go to the source to find the facts, to make correct decisions, build consensus, and achieve goals at your best speed. Under respect for people, there are two key commitments. Respect means respect for others. Make every effort to understand each other, take responsibility, and do our best to build mutual trust. And finally, teamwork. Stimulate personal and professional growth, share the opportunities of development, and maximize individual and team performance. In about 2005, we took this Toyota way of 2001, fleshed it out a little bit. It now has 4 principles we call the 4 Ps. Principles by which we behave and act, the planning process, the processes, and the people. We consider lean thinking to be a key concept within planning. We just described the 4 Ps, and within one of the Ps is planning. Within planning, we think lean thinking is a part of that. So now that I've given you a complete sequence of evolution starting from Kaizen in the 1937s to JIT, to TPS, to TQM, and the Toyota way, let me get back again to lean for a minute. What may surprise you is that lean thinking strategies are now migrating into other non-production environments, such as healthcare systems and the U.S. Armed Forces. By using lean thinking, National Health Services in England has reduced the time it takes to process blood samples from 24 hours to just 3 hours. In Texarkana, Texas, the Red River Army Depot repairs 32 Humvees a day, compared to 3 a week in 2004. The cost of repair for one of these vehicles has dropped from $89,000 to just $48,000. In the corner of every office and on all the shop floors at Red River stands a black cutout figure of a soldier. It serves as a constant reminder of who the customer is. And if you can't read it, I will read it for you. Building it as if our lives depend on it. Theirs do. Everyone in your organization should have that attitude. Management and production staff and everyone who supports them, that lives depend on doing it right the first time. Going back to the Industry Week and Bearing Point survey, I was really thrilled to see that the top 3 issues of senior manufacturing executives today are acquiring new customers, increase customer satisfaction, and increase customer loyalty. Customer, customer, customer. It's not about costs. According to Peter Drucker, the only purpose of business is to create a customer. He wrote this some 50 years ago. Most of us are getting it just now. I believe that by putting the principles of Toyota Production System to work, your organizations can not only improve productivity, it can increase customer satisfaction and customer loyalty. Whether you call it TPS, lean production, lean thinking, Six Sigma, Hoshin Kanri, total management, total quality management, or Toyota way, the basic fundamental tenets of these can make your organization more efficient, cost-effective, and customer-focused. That's it. Thank you, and I look forward to seeing your companies on the list of Industry Week's 2007 Best Plants winners. Thank you very much.